Hey Steve, I want to see a video where you solve using the law of cosines a triangle where the sides are ln(x), ln(2x), ln(3x) along with an angle that we know. Kind of like that time we did the Pythagorean theorem with the ln triangle. Thank you. Okay, so here I have this for you. Let's use the 60-degree angle because we know cosine of 60 degrees is 1/2. And this is not meant to be a right triangle. This is not 90 degrees. And of course, this is also not going to be an equilateral triangle because all three sides are going to be different. Notice this right here is the shortest, which is ln(x). And now, because this angle is 60 degrees already, when you go away from it, this side right here, in fact, has to be the second largest side. So that will be ln of 2x. And the reason for that is because once this is 60 degrees, that means this and that together have to add up 120 degrees. So you can just think about it as like maybe you have 50 here and 70 here, or 40 and 80 here. So this side will actually be the largest. So ln of 3x, like that. Once we have the setup, then we'll apply the law of cosines, which says when you have this angle and you go away from it, this side squared, so we begin with ln of 2x squared, that will be equal to the sum of the squares of the adjacent sides. So we have ln(x) squared plus ln of 3x squared. But this is not the Pythagorean theorem because this is not a right triangle. To continue with the law of cosines, we will have to subtract 2 times these two sides. So we have ln(x) and then ln of 3x. And then lastly, where's the cosine? Well, it's right here. We need cosine of whatever that angle is, which is 60 degrees. And now we are ready to just solve for x. And again, we know that cosine of 60 degrees is 1/2, and that cancels out with the 2 very nicely. And in order to solve for this, let's just break this down. ln(2x) means ln2 plus ln(x). So have a look. Here we get ln2 plus ln(x), and then we have to square that. That will be equal to ln(x) squared plus, again break that down, ln3 plus ln(x) squared, and then minus ln(x), and that's also break this down, which is ln3 plus ln(x). Now we just have to expand it and then distribute and collect like terms. So we are going to square this, so that means we have to square the ln2. Let me write it down like this. Plus 2 times this and that, so that's 2 ln2 ln(x) plus this thing squared, so that's ln(x) squared. And that's equal to ln(x) squared plus square the ln3. Add 2 times this and that, so 2 ln(x), ln3 ln(x). And then lastly plus ln(x) square, and then distribute this, so we will have minus ln(x) times ln3, and then lastly minus ln(x) square. I couldn't fit everything on one line, unfortunately. But anyways, let's see. It actually cancels out quite nicely. Have a look. Here we have ln(x) squared, and that's minus ln(x) squared, so this and that cancel. And then notice that the left-hand side of the equal sign, we have ln(x) squared, likewise this. So this cancels out with that quite nicely. And in fact, we actually don't even have a quadratic situation anymore. Yeah, we cancel all the ln(x) squared. So the rest is just pretty straightforward. We'll collect all the like terms. Notice this and that, they are like terms because they both have ln3, ln(x). So together it's just plus 1. And let me just write this down again. So this is ln2 squared plus 2 ln2 ln(x) equals, that's ln3 squared, and that is going to be plus ln3 first and ln(x). And that's it. It's not a quadratic equation in terms of ln at all. And now we just have to collect the numbers and all that. So let me move this to there. So we have 2 ln2 ln(x) minus ln3 ln(x), and that's equal to, bring that to the other side, and this right here is ln3 squared minus ln2 squared, And now notice we can factor the ln, so I will do that like this. This is 2 ln 2 minus ln 3, and then we have the ln x, that's equal to this. And now we just have to divide this, right? So that means ln x equals ln 3 minus ln 2. I know the square right here, okay? And then divided by that thing, which is 2 ln 2. And of course, you can also write this as ln 4 if you would like, but like, let me just keep it as 2 ln 2 minus ln 3. And lastly, to get rid of the ln, right, e to the power and e to the power. And finally, you can see that, I'll just write this down nice and big. X is equal to e raised to the power of ln 3 squared, and then minus ln 2 squared over 2 ln 2 minus ln 3. And that will be the x value. And of course, you guys can punch that onto the calculator and maybe let me know what the answer is. And just for fun, you can also let me know what the other two angles will be based on our computations. Yeah. In fact, this is much nicer than the Pythagorean one if you have a right triangle with 90 degrees, because thanks for this part, this and that cancel, so it worked out much better. Yep. Hopefully you guys all like this. That's it.